Welcome to Brain Vision.
So in this problem, we're asked to calculate the root mean square velocity and kinetic energy of fluorine, chlorine, and bromine gas at 298 Kelvin, and then rank them with respect to their rate of effusion. So the first thing we want to do, let's look at F2. I've written down the formula for root mean square velocity here. And so all we really need to do is plug this in. So 3 times 8.314 times 298 divided by the molar mass of fluorine gas, be 19.00 times 2. And now because our 8.314 is in joules, this has to be in kilograms. So normally this is in grams. To convert to kilograms, multiply by 10 to the negative 3. You can plug this in. 3 times 8.314 times 298 divided by 19 divided by 2 times 1000, and then take the square root of that. 442.3 meters per second. And do the same for chlorine. The constants on top are the same. You just change the molar mass, 35.45. You plug that in and you get 323.8 meters per second. Finally, you got bromine. You plug this in and you get 215.7 meters per second. Okay. And so this is the answer to part A. Let's look at part B. Now, if we assume all these gases are ideal, then we know that temperature is just average kinetic energy. So their molar mass wouldn't matter. Okay. And in fact, the formula for kinetic energy is just 3/2 kT, where K is Boltzmann's constant. Boltzmann's constant has a value of 1.38 times 10 to the negative 23rd joules per Kelvin times 298 Kelvin. And we can plug this into a calculator. And we get 6.17 times 10 to the negative 21 joules. This is for each individual particle. Finally, for part C, all right. We know from Graham's law that the rate of effusion is inversely proportional to molar mass. Oh, I forgot a 2 here. And this is backed up by this RMS velocities that we calculated. Okay, the larger the molecule, the slower it moves, so the slower it would effuse. Okay. So if we were to rank them with regards to their rate of effusion, Br2 would effuse slower than Cl2, which would effuse slower than F2. Because as you get smaller, the molecules move faster and they would escape from a pinhole faster. So that's the problem.